Okay, in this video lesson we are going to be finding the area of parallelograms and trapezoids. Let's look real quick at the student expectation. 6.8D says to determine solutions for problems involving the area of rectangles, parallelograms, trapezoids, and triangles. I'm going to stop there because that's the part of this SC that we are concentrating on. And again, we're looking at area of rectangles, parallelograms, and trapezoids. Let's go and do a quick review. Be sure that we're understanding area. The definition of area is the number of square units needed to cover a given surface. So here's a diagram of a given surface, and it has the measurements: 5 units here and 2 units here. And when you draw everything, you end up with 10 square units. Now, you may remember to find the area, you can multiply the length times the width, or base times the height, and 5 times 2 is 10. I'm going to show you again the formula. You may have seen it as length times width. Area equals LW. You're going to now see it as area equals BH. It's not any different, it's just the terminology. We're talking about the base and the height. Okay, so let's look at some vocabulary very specific for this lesson. And we're talking about parallelograms and we're talking about trapezoids. Okay, now definition. A quadrilateral with 2 pairs of parallel sides is the definition of a parallelogram. So you can see in this diagram that the top and the bottom sides are parallel, and then the left and the right sides are also parallel. So we have 2 pairs of parallel sides. In the trapezoid, it's a quadrilateral with exactly 1 pair of parallel sides. Now, quadrilateral simply means that it is a 4-sided polygon, or it is a closed shape with 4 sides. Both of these have 4 sides, but the trapezoid specifically only has 1 pair of parallel sides. So you can see in the diagram the top and the bottom are parallel, but not the left and right side here. Okay, so let me show you the formula, and remind you, we learned in class when we looked at the parallelogram, the formula was A equals BH, which is just like a rectangle. Now, we learned in class that a parallelogram can actually be constructed from a rectangle. So, as long as we can find the height of the parallelogram, we can simply use the same formula, A equals BH, because really what we do have here is a reconstructed rectangle that is a parallelogram. So we use the same formula. Okay, the trapezoid is a little bit more difficult, and let's review also what we learned in class. What we did is we created an identical trapezoid, and we kind of set it upside down, and what we did is we recreated a parallelogram, because we know how to find the area of a parallelogram. And what we need is a base and a height, but we understand that the base of this parallelogram is made from the top, or the bottom and the top of the original trapezoid. So what we call it is base 1 and base 2. And then we add those together so that we can get the base of the parallelogram, and then we find the height of the parallelogram. We multiply that, but what we have to remember is that we're only using the parallelogram to help us with the formula, but really all we're looking for is the area of this one trapezoid, which would be half of this parallelogram. So it looks complicated and it sounds complicated, but we'll do some examples to try to understand it. But let's go ahead and write the formula. So it's the area is 1/2 of base 1 plus base 2, and then times the height. All right, so that's a look at the formulas. And again, these aren't formulas that you actually have to have memorized because we have the formula chart, but you do need to understand them and what the different parts stand for, the B and the H, and why it says half and why is there two different B's here. All right, but don't forget the formula chart. This is what it looks like. This is actually one side of the formula chart that we've looked at already. And then there, of course, is the other side. And this is the part that we'll be using with this lesson, where it gives us the formula for area. And we have triangles, rectangles, parallelograms, and trapezoids. Right now, specifically, we're working with the rectangle parallelogram and the trapezoids. So you'll see this is the formula for the parallelogram and the rectangle. And then the trapezoid is this formula. Okay, so let's look at some practice problems and see if we can use these formulas. Okay, so here we have a window in the shape of a parallelogram, and it has a base of 36 inches and a height of 45 inches. And the question is, what is the area of the window? All right. First thing we probably ought to do is draw a picture of this parallelogram. So I will do my best here. So it's 36 inches is the base, and the height is 45 inches. All right, so here is our height, and that's 45 inches, and then our base is 36 inches. All right, so let's use the formula. And the formula, area of a parallelogram, is A equals BH. And let's plug in our base and plug in our height. So we have 36 is the base times, and I'll put that in parentheses, times 45. Now it's just a matter of doing the multiplication. So I will come over here and show my work. 36 times 45. 6 times 5 is 30. Carry your 3. That's 18. All right, let's add 0. 6 times 4 is 24. And then when we add all that up, we get 1,620 square inches. 1,620. And since we're talking area, it's inches squared. 1,620 square inches. All right, practice problem number 2. A section of a patio is in the shape of a trapezoid. What is the area of this section of the patio? All right, so obviously you can see here that we have a trapezoid. Let's go ahead and just plug in the formula, or let's start with the formula. Area equals 1/2, and then in parentheses, base 1 plus base 2 times H. Earlier I showed you the diagram where we draw an additional trapezoid that's the same size and turn it into a parallelogram. But for this one, let's just go ahead and plug in our numbers into the formula and work through it. So I'm just going to keep the 1/2, and I'm going to do my order of operations. I want to do the parentheses. So inside the parentheses, we have a base 1 and base 2. So base 1 and base 2. So 35 plus 15. And then we will multiply by the h, which is the height, and it's given to us right here, which is 14. All right, so inside the parentheses then we have 1/2 of 50 and then times 14. Now, you could actually do this in any order based on the associative property of multiplication. You could find half of 50 and then multiply times 14. You could actually find half of 14 and then multiply by 50. Or you can multiply 50 times 14 and then find half of all that. Again, associative property of multiplication says you can do that in any order. I'm just going to go from left to right here, and I'm going to say half of 50. And half of 50 is 25. And now I need to multiply 25 times my height of 14. That's just a matter of doing the multiplication. So let's go ahead and work it out. 25 times 14. And you will see that the answer is 350. And because in our diagram the measurements are in feet, it's going to be 350 square feet is going to be the area. Okay, and that is a look at finding area of parallelograms and trapezoids.